So next class, we're going to continue to develop our understanding of Hilbert-style proofs, and we're going to start to look at more Hilbert-style proofs to better understand them. So the learning outcomes for next class will also be to write Hilbert proofs, equivalently gamma proofs, or theorem calculations from gamma. Before we continue with our Hilbert proofs and section 2.1, let's try and make a clearer distinction between what we mean by inside logic versus the metatheory. So I know this is something that's still a little bit elusive for us. So now that we have completely developed our logic, right, not only what a well-formed formula is, but also what our logical axioms are and completely what our logical system is, we can start to better understand the difference between inside logic versus the metatheory. So we know at this point that what we learned in 1.1, so formula calculations occur inside logic, and also theorem calculations occur inside logic. We also know now that a theorem inside logic is simply a well-formed formula. So when we're talking about theorems, when we're working in logic, or trying to prove theorems, or write Hilbert proofs of theorems, we simply mean that we're trying to write a Hilbert-style proof of a well-formed formula, right? Because theorem calculation, similar to formula calculation, is written in steps, and each step is simply a well-formed formula, and any theorem is simply any well-formed formula that can be written at a step of a theorem calculation, following these particular rules. We will, however, often abuse notation and use symbols outside of logic as a shortcut to ask you to do something. So for example, when we want to ask you to write a gamma proof of A, which you will do with inside logic, we'll simply ask you to prove gamma proves A. This is a statement outside of logic because, for example, this symbol, meaning proves, is not within our Boolean alphabet. So the only thing that's inside logic is the well-formed formula A that we're asking you to prove. And we will use our Hilbert-style proof, which is something that happens in logic, to be able to do that. So even though this statement appears to be outside logic, what we really mean is for you to prove A inside logic using a Hilbert-style proof, at least at this point. So, as I mentioned, this is a statement within the metatheory, and we will develop in the next video a variety of different metatheorems to help us understand logic, to take some shortcuts. So as I just said, gamma proves A is technically a statement in the metatheory, and metatheorems are theorems about logic, and we're going to look at some of those in the next video. And you'll see that often metatheorems are statements, so they're English statements with words that talk about what we know about logic if we're looking at it from the outside, but we're going to be able to use these metatheorems to help us to take shortcuts in writing proofs. So you'll see in the next video how, as I mentioned in class last time, how we're going to be able to use what we're proving to help us take shortcuts in our proofs. So we're going to adjust using what we know about studying logic from the outside, so what we know in the metatheory, to add essentially different steps within our definition of a theorem calculation. Okay, so next we'll look at some metatheorems and how these shortcuts will help us to write Hilbert-style proofs.